This is the Mathematics Education Podcast from mathedpodcast.com. Welcome to the Math Ed Podcast. My name is Sam Otten from the University of Missouri, and today my guest is Dr. Mike Shaughnessy, who's a professor emeritus in the Department of Mathematics and Statistics at Portland State University. Mike, thanks so much for being here.
Thanks, Sam. It's good to talk to you today.
We're going to be looking back at Mike's career in mathematics education and focusing particularly on his scholarship throughout the years. But Mike was also a past president of the National Council of Teachers of Mathematics, so I imagine that might come up as well. But let's get started right back at the beginning. When was it that you first realized that you wanted to pursue a career in mathematics education or mathematics and statistics education?
Well, when I started, Sam, there wasn't anything like mathematics education as a discipline, and I was a mathematics major as an undergraduate, and then decided to do a master's in mathematics at Indiana University. And during the time that I was in Indiana University, I got more interested in teaching. Indiana University had some colloquia that were, at that time, focused around mathematics education and teaching, so this would have been in the early 1970s. It's a long time ago. I got thinking, well, maybe to try to find where to do an advanced study in mathematics education at that time was rather difficult. But when I was finishing up my master's, there was a new program in mathematics education in the math department at Michigan State University. And I applied for that and was accepted in. And so that was the beginning. Mm-hmm. I was always interested in math, but I sort of got interested in math teaching because of a few more in math education, as I thought, well, I might be interested in learning more about how kids think. That's really where I started.
Yeah, and can't go wrong with Michigan State, I must say myself.
Yes, we have a common alma mater there, don't we?
Yeah, and I also noticed back in the early 70s, you read Erlwanger's piece because in the classics from NCTM, you gave the kind of foreword or the introduction to Erlwanger's Benny piece.
So it looks like maybe you've done a little homework on this, huh? Yeah, I got asked to do that one as part of that classics volume. We got a number of people nominated possible articles for that, and I nominated the Benny article because it really struck me in a big way. I think I mentioned I was interested in how kids think, and that was very timely about the time that I was a beginning graduate student. It was one of the first pieces that we read in mathematics education seminar at Michigan State, and it was a big deal at that time because there was a lot of individually prescribed instruction that was going on, where kids were kind of working through procedures and booklets. That's the kind of curriculum that was out there at the time. Mm-hmm. And so Erlanger discovered that kids were inventing, in particular Benny, inventing his own procedures. Very clever, and managed to get through courses, without really understanding what was going on.
Mm-hmm. So you mentioned that one coming up at the beginning of your grad studies. Can you tell us a little more about grad school at Michigan State? What was that like?
This is a brand new program. It was in the math department. So I was basically a mathematics PhD as well as a mathematics education PhD. And the program was such that we took all of the same coursework and prelim exams in mathematics as folks who did their research in mathematics. Mm-hmm. So it was kind of an intense program, because after doing that, only then did we really start to do the mathematics education piece. Although, all along the way, the whole 4 years that I was there was a special course or special section for those of us interested in math ed. And we concentrated one time on research, one time on history of math education, one time on curriculum in mathematics education. That was kind of the focus of our work at that time. It was a very early in the development of math ed programs, very early version.
Right. And who was it that was involved there at Michigan State on faculty?
Yeah, so the folks that were there at that time were John Wagner, who had actually helped Ed Beagle with the SMSG project in the 50s. Mm-hmm. Lauren Woodby was a curriculum specialist, and Lauren was a really interesting character because he had also helped develop radar in World War II. And Bill Fitzgerald was both a mathematics and a science specialist. Bill was my major professor. He was very interested in laboratory approaches to mathematics with kids and with pre-service teachers, and a lot of hands-on activity. And he really had a big influence on my own thinking. The other person who was there at that time was Glenda Lappin. She was just starting out as a young assistant professor.
Okay.
Betty Phillips was also there, and Betty was a big influence on me as well, because I worked with Betty and Tom Butts on some writing in algebra.
Mm-hmm. So there's the team is kind of forming who would later go on to write the Connected Mathematics Project,
That's
which a lot of people might be familiar with.
Exactly right, and they went through an interim curricula of some units called the MGMP, Middle Grades Math Project Materials. And some of the units that they developed for the MGMP project eventually morphed into pieces of the Connected Math.
So now for yourself, after you finished up the mathematics requirements and exams and things, and then you could focus on mathematics education, what did you focus on for your dissertation?
So toward the third and fourth years when I was at Michigan State, I got taking some coursework from Lee Schulman in the School of Ed. Lee is a master teacher and just knows a lot about lots of different areas of mathematics education, and he had a seminar on problem solving and decision making. And it was interdisciplinary. There were, I guess, about a dozen of us from all over the university. And one of the things that came up in that problem solving and decision making seminar was some research on decision making under uncertainty and the influence of people's intuitive thinking in probability and how that can lead them astray in terms of estimating the likelihood of events. I found that fascinating, and it actually got me started on researching some work that the psychologists had done on the use of heuristics in probability, and particularly Daniel Kahneman and Amos Tversky back in the early 1970s. And so that's how I got started. I got my dissertation topic out of that to try to teach a course. It's an introductory undergraduate students. So these were kids just right out of high school. And so I got my hands on it. The math department was very kind and let me teach a section and let some other people teach some sections of a course that I created, sort of a hands-on experimental approach to learning probability. The question was, would that approach help in changing the way folks believe certain probability things should be? It's just kind of a quick overview.
So the probability and statistics piece we'll see continue through as we go forward in your career. But in the mid-'80s, you also did some work in geometric reasoning. I was wondering if you could just tell us about what was going on at that time and how you ended up making those contributions in geometric reasoning.
It's interesting. The same seeds of the geometry occurred at Michigan State in that seminar as well. Right about the time I was finishing at Michigan State, I was just starting my research my own research in probability. In our seminar, we had a couple of papers, some by Russian researchers and one by Isak Versip, who had been working with Russians and visiting Russia on geometry and kids thinking in geometry. It was the first time in the United States that we had heard about the von Healy's model of geometric thinking. And that was pretty fascinating. In fact, it led to a whole year of seminars on geometry and different approaches to geometry at Michigan State. So we had a series of speakers that came in at that time. So I found that kind of interesting. But then when I got to Oregon State University and started as an assistant professor there for a few years, after a couple of years, Oregon State hired a fellow named Bill Berger. And Bill had been a graduate student at Ohio State University at the same time I was at Michigan State. He'd read some of the same papers. He was very interested in the von Healy's work and wanted to see if we could explore kids' thinking from basically kindergarten up through graduate school in geometry and look for sort of a trajectory that might in some sense validate the von Healy's 5 levels of geometric thinking and also just give us better information for how maybe we should approach the teaching of geometry both at middle school and also at secondary school. So he and I and Alan Hoffer put a proposal in the National Science Foundation, and we're funded to do some research on kids thinking. So that's how the geometry stuff started. And that took up probably 4 or 5 years. And during that time, I literally got away from research in probability and statistics for a while,
Mm-hmm.
and was appropriately chastised by my colleagues at the, when are you coming back to statistics? I can
Mm-hmm.
just hear some of the folks saying that. It was also, I think, right at a time in the mid-1980s, statistics education was beginning to have a nucleus of folks who were interested in it as a sort of almost separate discipline from mathematics education. There wasn't any, separate area called statistics education until after the first ICOTS meeting, International Conference on Teaching Statistics. I think that really launched the whole notion of not only is statistics a separate discipline from mathematics, but statistics education in itself has its own unique kind of approach because of the discipline of statistics being different in many ways than mathematics. So that in the mid-1980s, there was really a sort of the beginnings of what is now a rather growing and strong group internationally in statistics education. And it got seeded by those ICOTS conferences and subsequently by some folks at the University of Minnesota, in particular Joan Garfield, who is really I would consider Joan the mother of the discipline of statistics education, particularly in the United States.
So then let's just follow that train of thought. As you personally were able to reactivate and get going again in statistics education, just talk to us about how that began or how that kind of restarted in the late 80s and into the early 90s. What were you working on and thinking about there?
I had an opportunity to go on sabbatical, I think it was 1990, in Australia and New Zealand, and work with some statistics educators down there, with Maxine Von Cook in particular at the University of Auckland, and Jane Watson at the University of Tasmania. And Maxine at that time was starting to think in her own work about what statistical thinking involves. And she was working on a model of statistical thinking that was based on what statisticians do. Jane and I, both right about the same time, became very interested in variability as the main issue in statistics, and how little research had been done around the concept of variability and variation. So much of it to that point seemed to be on kids thinking about centers and mean, median, and mode, and a lot of the materials, that teachers, especially in middle school, teach, or at least taught at that time, were all around measures of center, when really the big issue in statistics is variability. So we began to devise tasks that we could give to kids to see how they were thinking about variation and variability, and started out with some sampling tasks in particular. Sample from, a big bin, let's say, of candies that that there's a certain percentage of red and black and yellow ones there, and you grab a handful. How many of each color would you expect, and why? And if you sampled again, how many would you expect? And would kids think that things should change, or would they think that, well, it should always be really close to the same? So that was kind of the seeds of what eventually led to some research that we did here in the States, but also that Jane did for a long time in Australia, on kids thinking about variation and variability, and eventually sampling distribution.
I'm going to jump ahead a little bit, but you received the NSF Roll grant to do some additional work on statistics, and again, focusing on variability. This was in, I think, if I have it correct, 2004 to 2008. Right. So just looking back to the NSF Roll project, I was wondering what motivated that project, and then what do you look back on as some of the main contributions from that project?
A couple of things. We wanted to get a better idea of how middle school and secondary school kids were thinking about variation. We wanted to try out some teaching tasks. So it was kind of a modified teaching experiment. We had some teaching episodes. It wasn't the traditional, teaching experiment methodology. It was kind of mixed. We had some week-long co-teaching with regular teachers in both middle schools and secondary schools for a week or so, both before and after we did those teaching episodes with the kids. A lot of them had to do with sampling and measurement variation when you measure objects and the repeated measurement. We wanted to see if kids thought differently, after that intense week-long experience. We had them 2 hours a day for 5 days. So we were able to do some extended kinds of hands-on experiments and sampling things with students. We did interventions, I guess, over about a year and a half period of time with the same students in the same schools, and then kind of tracked their growth and thinking about variation and variability over time. We also had some matching classrooms that didn't have those teaching episodes, so we were able to do some comparisons between kids and classes who had our teaching episodes on variation and those who didn't. It's kind of, big picture, nutshell kind of. Big takeaway is really hard to it's really difficult to get some kids to think in terms of variation or variability. They're really honed in on centers. Mm-hmm. So, for example, if you ask kids to predict what would happen with repeated samples, they might say, well, it's supposed to come out a certain percentage. If you know there's 60% red in your mixture, and so you really should get 6 out of 10 or 60 out of 100 red. It might move just a little bit one way or another if you took repeated samples. So some kids are really kind of pretty honed in and stuck on that, and to me that's an outcome of the way we have been teaching probability. Sort of a fractions ratio kind of thing rather than thinking about variability as the main issue at the beginning.
Right. So would just one piece that they're kind of missing on is that if you take more and more samples, you actually might start to get something that's like all red. It's like, oh, I got a sample that's all red, but it's because I took 1,000 samples.
Right.
Where like the students might kind of miss that fact that you might get some of those outlier samples if you take enough samples.
Well, the whole point is to sort of be able to think in terms of a distribution of outcomes rather than a single outcome or just a few outcomes.
Yeah.
So
you might get this all red sample, but it's going to be 1 out of 1,000, and then you're going to have 600 of them that are going to be pretty close to the ratio that they're expecting.
Right. I think another takeaway is that it is the concept of spread or distribution of things is something that kids can handle and take on much earlier than they usually get a chance to see it. I mean, traditionally haven't seen anything like that until college, unless they maybe are in an AP statistics course or something like that. But middle school kids are perfectly comfortable. In fact, in some cases, the middle school kids actually took on and thought more in terms of variation than some of the high school kids who had a little bit more of traditional math up to that point. So.
Now, you not only did your own research in statistics and probability education, you also did some synthesizing of the research. You actually had the distinction of writing chapters not only in the first handbook on math teaching and learning, but the second one as well. So I was just wondering what your experiences were like writing those 2 handbook chapters.
Well, first, when I was asked to do the first one, I was really surprised and honored. Also, that was when that happened. That was fairly early on in the whole development of statistics education research or research on probability. And at that time, it was actually possible to almost be able to read and pull together everything that existed up to that point because it wasn't that much. So the first chapter, that it was a great experience for me. I just learned a lot and was able to pull a lot of things together. And I tried to write both those chapters in a way that would be accessible to future graduate students. So they would be readable, and also hopefully that students would go then back to the original sources, which doesn't always happen.
Yeah.
Sometimes people will quote the handbook chapter rather than saying, well, go back and read the original source and for yourself as well. By the time the second one came around, Sam, research in statistics education and on statistics had boomed. There was less new research on probability. And so that second chapter really was more on what was known at that point. And it was also just at the beginnings of some of the research that we had done on how kids think about variation and variability and how kids were thinking about distribution. Now, there's a third one, which I think is in the hopper now.
Yeah, that's right. Yeah, I was curious if you have any things you're looking forward to from the new handbook.
Well, one of the things I'm looking forward to is how our chapter is going to turn out. So the first 2, I authored the chapter. The second one was on statistics, and it was a separate chapter that was done on research on probability on the second There was so much then that they had to split them. This third handbook now is back to having a chapter that is trying to cover both probability and statistics education research since the last one. And there's a team of authors, and it's an international team, so I think it's a healthy approach to have a team, but in particular to have an international perspective. Hopefully it will be this third handbook will be even read by even more folks and useful to the international community more than just the U.S. and Canada.
Mm-hmm. Is there anything that particularly strikes you in the time since 2007 to now as a new contribution or a new piece of knowledge that's been gained in stats and probability education?
Well, there's been a lot of movement towards what's called informal inference. Mm-hmm. People use that term informal inference, and I don't think everybody means the same thing by it when they use it. There are ways to introduce the whole process of making inferences through simulations and bootstrapping and basically generating sampling distributions and making decisions based on how likely certain outcomes are in your sampling distribution. So it gets a little bit away from theoretical probability distributions. That's one thing that's pretty big in a direction that it's gone since that time. There's uneasiness in the community about that in some areas. There are folks who feel that to try to do, and I think they're right actually, to try to do inference without probability is maybe not a good idea and not useful. So somehow or other, what I would like to see as we go ahead is for the probability perspective on inference and sort of the repeated sampling perspective for those two to merge in the teaching of statistics. And in fact, they have. There are folks who do that and do it very well. In particular, I think Alan Rossman and Beth Chance at Cal Poly have a really good approach to statistics, to the teaching of statistics that gets at the use of probability, but from a sampling point of view.
Mm-hmm. And with a name like Chance, it's very fitting to be researching probability.
So maybe Beth and Alan would be people that, if you haven't interviewed yet, that you might interview sometime too.
Yeah, absolutely. And are there other areas of future research that you would kind of point the field in?
Well, for both mathematics and statistics education, there's begun to be a lot more research on teaching in the last, I think, 10, 15 years. And there hasn't been that much in statistics and statistics education, just research on the teaching of statistics. And in particular, it's something that I shared at the last ICOTS meeting, which was in Flagstaff, Arizona. If there's approaches to teaching, be it mathematics or statistics, that really get at and try to highlight discourse in the classroom, student discourse with each other, to bring out how they're thinking about things and to share their thinking publicly and to use those public records of their thinking to sort of push the ideas ahead. So it's a very different approach to teaching than traditionally has, where the students are actually doing more of the talking and interacting, and the teacher is navigating and directing and trying to structure the student talk in a way that it makes progress. There's been some research on that. I'm actually involved in a project that's doing that with some elementary school teachers in a large school district in the Northwest right now. I'd like to see that same kind of thing happen with the teaching of statistics and have statistics educators work in classrooms with teachers the way we're currently working with these grade 3 through 5 teachers. Sort of change the way that statistics has been taught.
Yeah. And that's, starting to get into my wheelhouse, too, because I'm very interested in the ways that students do talk in class and how that's used to push the ideas forward. So I think that's some good stuff. My guest is Mike Shaughnessy from Portland State University, who is a past president of the National Council of Teachers of Mathematics. And so we've been focusing primarily on your scholarship, but I am curious about your NCTM presidentship. So what would you say were the biggest challenges and the biggest benefits of that job?
When I became president, within a day, actually it was when I was during my president-elect year, within one day the Common Core was announced. And I spent my presidency trying to navigate the political waters of dealing with the Common Core and with forces where things were happening in mathematics education that were outside of the realm and influence of NCTM, but on the other hand, that they were building on a lot of the ideas that NCTM had put forth over a 30, 40-year period of time through all the standards documents, both the 89 standards and the 2000 principles and standards for school mathematics. So part of it was just trying to find where NCTM could help teachers and support teachers during this time that we have been experiencing the last few years while the Common Core has been rolled out and while the two big assessment consortia have been rolled out, to try to get other groups like National Council of Supervisors of Mathematics, Association of Mathematics Teacher Educators, and to bond together and then work with the folks who were writing and developing as best we could and offer whatever we could in the way of, try to get our foot in the door in the conversation, basically. That was a very, very big challenge. In some sense, it's one of these things that we'll see how the Common Core plays out over time. That's another conversation that we could have that I don't want to take up too much more of this time, but just to let you know that National Council of Teacher Mathematics ideas that have been there are very strong and still go on, and I think will survive and outlive many, many things, and including whatever the Common Core morphs into over time. Benefits, to be able to contact and meet with and work with the leaders at the state levels of so many different states, to visit. I gave, talks and presentations and worked with the state councils of 35 different states while I was president. In fact, last week I finished off maybe the last one of those when I did a presentation at the Vermont Council of Teachers of Mathematics just this past week. To see the excitement and the dedication of so many folks that work on the NCTM committees, the volunteers who work on NCTM committees. It was my job to recruit folks for those committees and tap them and ask them. And I think there was only one in maybe 200 people that I asked that said, no, I can't do it. So it was amazing. Everybody was very, very grateful to be asked, and is usually served very, very well on those committees. So that, and also working with a really, really good NCTM staff. Those folks are terrific at headquarters.
Well, we all appreciate your service that you did at that leadership level. I actually want to finish with a question that's going to go a bit different. Now, looking back at this career that you've had and all the different roles that you served, and now enjoying your emeritus status, although somewhat involved, it sounds like, still at Portland State. But if you were looking back and actually could imagine a different career, not mathematics or statistics education, what might that have been?
No, not mathematics or statistics education. One thing that occurred to me is that it might be fun to actually be what I would call a real statistician. Work a lot with data and getting information from data. But in the spirit of your question, I think maybe something in music. And I've always been interested in music and kept it as part of my life. I sing in a choral group here and have for about 20 years in Portland. Play a couple of instruments, not well, but could see that it'd be really fun to go in that direction.
Yeah.
The only thing is I probably would have made even less than I have as a teacher.
Yeah, but it's about the reward of the work. So.
Indeed.
Well, Mike, thanks so much for taking this time to just look back through the decades. We really appreciate hearing your perspective on your work, so thanks for sharing. Well,
Sam, thanks a lot for having me on, and I hope that your podcasts continue to reach teachers and researchers. And if any of them have any questions that they want to follow up with, they can reach me at my email address, which is mikesh@pdx.edu.
Well, thanks very much for the kind words, and you can tell that you used to have a presidential position because you're very open to access, so that's great to hear.
Thanks a lot, Sam.